Good morning students, welcome to the Science 1 class. In this video, we are going to learn about modern periodic law and modern periodic table. In the previous video, we learned about the Mendeleev periodic table. As the number of electrons discovered being increased, and fitting them into the table according to the periodic law by Mendeleev seems difficult. In the year 1913, Henry Moseley, British physicist, said that instead of atomic mass, all the elements will show periodicity if arranged on the basis of their atomic number. Henry Moseley thought that the characteristics of elements are based on their atomic numbers and not on their atomic masses. With this concept, there emerged a new law of studying the periodicity of elements. It was called the modern periodic law. The law states that the properties of elements are periodic function of their atomic numbers. It means that the physical and chemical properties of the elements occur periodically, and it happens when the elements are arranged based on their atomic numbers. So far, we have discussed about the history of the periodic table. Now, we are going to learn in detail about the modern periodic table. Periodic table has 7 rows and rows are called periods, and it has 18 columns and columns are called groups. Now, let's number the boxes in the periodic table. Complete the first row and then move on to the second row. These numbers look like roll numbers. Do you know what they really are? They are atomic numbers. So, atomic numbers are number of protons present in the nucleus of an element. And you know that this is the major difference between Mendeleev periodic table and modern periodic table. Mendeleev table was based on atomic mass, but the modern table is based on atomic number, because the scientist Moseley proved that the atomic number is the more fundamental property for elements as compared to the atomic mass. Chemical properties are related to atomic number than the atomic mass. Now, let's fill the elements in the table. What is the first element with atomic number 1? That is with 1 proton in the nucleus. Yes, it's hydrogen. Let's write the symbol of hydrogen, H, in the first box. Next, with atomic number 2, we have helium. And the second row starts with lithium. And it goes on like this till the last element, that is 118th element. With every element, the atomic number is increasing by 1. What does it mean? 1 extra proton is being added in the nucleus. Then, how is the electron number changing? Electrons are also increasing by 1 because an atom is neutral. It has equal number of protons and electrons. Now, let's learn about the significance of the period. You know that totally we have 7 periods or rows. Let's take first 4 periods. What this period number tells us? It tells us about the number of electron shells present in an atom. We can predict the number of shells even without drawing the electronic structure. For example, hydrogen is in period 1 and it has only one shell. Next example, oxygen. And oxygen is in period 2 and it has 2 shells. How many shells does aluminium have? Yes, 3 shells since it is in period 3. How many shells does calcium have? Yes, 4 shells as it is in period 4. So, with every new period, one more shell is being added. Let's see the electronic configuration of few elements. Students, you have learnt about electronic configuration in class 9. I hope you remember. First, let's see the electronic configuration of hydrogen. Its atomic number is 1 and it is present in the period 1 and has only one shell. Next, electronic configuration of oxygen. Its atomic number is 8. It has 8 protons and 8 electrons. Students, you know that the first shell can hold only maximum number of 2 electrons and the following shells can hold maximum number of 8 electrons. So, here the first shell has 2 electrons and the second shell 6 electrons. Oxygen is in period 2 and has 2 shells. Next example, aluminium with atomic number 13. Electronic configuration is 2, 8, 3. As aluminium is in the third period, it has 3 shells. Next example, calcium with atomic number 20. Its electronic configuration is 2, 8, 8, 2. As calcium is in the fourth period, it has 4 shells. Now, let's learn about the significance of the group. We will always group similar things together so that it will be easy for us to identify. And simple example for this is the grocery store, where you find similar things grouped together. For example, you will find all the vegetables together, chocolates together, etc. Similarly, in the periodic table, elements having similar chemical properties are grouped together. Totally, we have 18 groups. In group 1, except hydrogen, all the elements in group 1 are metals. They are called alkali metals and have similar chemical properties. They have the same valency 1. What is valency? It is the number of electrons in the outer shell. Group 2 are called alkaline earth metals and they have the same valency. How elements in the same group have same valency and similar chemical properties? It is based on the arrangement of electrons in the atom, that is electronic configuration. Now, let's analyze the electronic configuration of elements in the same group. Let's take group 1 elements: hydrogen, lithium, sodium, potassium, etc. And they have atomic number 1, 3, 11, 19. Let's write the electronic configuration. Hydrogen has only one electron, so 1. For lithium, it is 2, 1. Sodium, 2, 8, 1. Potassium, 2, 8, 8, 1. What these elements have in common? Yes, they have one electron in their outermost shell. That is one valence electron. So, all these elements have the valency 1. And why do they have similar chemical properties? Because the chemical properties depend on the number of valence electrons. Now, let's look at group 2. We have beryllium, magnesium, calcium, etc. Let's write the electronic configuration. Beryllium with atomic number 4 and its electronic configuration is 2, 2. Magnesium with atomic number 12 and its electronic configuration is 2, 8, 2. Calcium with atomic number 20 and its electronic configuration is 2, 8, 8, 2. All these elements have the same number of valence electrons. That is 2 valence electrons. They have the same valency too. Hence, they show similar chemical properties. Elements in the same group have same valency and similar chemical properties. You might have seen the colorful pictures of the periodic table where the colors represent the different types of elements. For example, metals, non-metals, metalloids and noble gases. Group 1 elements are called alkali metals. Group 2 elements are called alkaline earth metals. Group 13 is called boron family because boron is the first member in the group. Similarly, group 14 is called as carbon family. Group 15 is called as nitrogen family. Group 16 is called as oxygen family or chalcogens. Group 17 is called halogen family. And the last one, group 18 are known as noble gases or inert gases. Now, look at periods 6 and 7. The elements with atomic number 57 to 71 and 89 to 103 are arranged separately below the periodic table. It is done just to compact the periodic table. The elements 57 to 71 are called lanthanide series because they start with the element lanthanum. Elements from 89 to 103 are called actinide series because they start with the element actinium. Okay students, that's all for today's class. In this video, we have learnt about modern periodic law and modern periodic table. Thank you students. Have a good day.